Okay, real quickly, I want to summarize the problem I actually did solve. It wasn't exactly the one I set out to solve because of some issues here. But what I did solve was I solved a problem that looked exactly like this with the spring, but here's what I did. Oops. I did not have this. I had 1 e to the 6th and I of being 1/12. So everything else was the same. What I had done again is I had gone in, and this is the x coordinate, so the node would be 1, okay, put a circle, 2, 3, 4, 5, 6th node, or this is the x value. At the 6th node, I pulled the deflection off. When I ran the code, okay, so what you saw me doing was this. I came in and initially typed on the command line, delta was equal to 0. Then, when I run the code, it says the force placed at that spring location was simply 100 times the delta. Well, the delta initially was 0, so the force applied to node 6 at location 10 was equal to 0. When I got all done, I had a new value of delta. Delta was equal to the deflection at node 6. Node equals 6, which was x equal to 10. Then when I came back and ran the code, delta was no longer 0, and I multiplied it times 10. Now what I did is I put a minus sign there because I'm pushing upwards. And so I did this loop over and over and over and over until essentially I'm doing this loop until I notice the delta doesn't change anymore, or the deflections everywhere don't change, and then I'm done. So essentially I iterated on this to create a load that was proportional to the node's deflection. I hope that makes some common sense here. What I'm going to do now is I'm going to do this in the 2D sense. The only issue I have here in the 2D sense is how do I get the I? Primarily in the 2D, which you can now think you're in a 2D type situation, you need to have a beam which is tall and thin. So here's your thickness, here's your height, and this beam runs backwards for a value of 20 feet. So it's 20 feet here. Now if I'm doing this, my I is equal to 1/12 base, or thickness times height to the third. I can no longer do what I was talking about before because my I is equal to 1/12. So I need a combination such that T times H to the third is equal to 1. So I can arbitrarily pick 0.001 to make it a thick beam. If I do that, H to the third has to be 1 divided by 0.001. Divide that out. H is equal to what? Oh, I don't believe I have Scilab up, but I do have MATLAB on the other screen. What do I get? I get a value of 10. That's too big. So how do I get this to be smaller? Well, let's try 0.01. Well, then I get if I get 0.0, if I get this value, my height can be 4.64, which I'm going to accept this. It may not be perfect, but I'm going to accept this to run my 2D case. My 2D case will have a thickness equal to this, and a height of that beam equal 4.64. And I'm going to take off and do the 2D case now.